In this video, we're going to start to talk about database transactions. So we have all of the steps that we know that we can do in SQL, especially in the data manipulation language. We can select data, insert data, delete data, update data. And so we have these uh, transactions, these ways of looking at data, changing data. Um, and Individually, those could be a transaction, but typically our notion of a transaction is sort of grouping these things together in a way that sort of makes sense to reflect the sort of the outside world that was meant to be represented by the data. So the transaction is some interaction and maybe like a human user of the database, but it also may be some application and it involves we're working within the data manipulation language, so there's select, delete, insert, update. Um, but we're going to group things together in larger units, most likely. Okay. So we're not going to change like one field or even a couple of fields in a single record, but we're going to do a set of uh, changing, accessing, and so on that should be, and it could be also insert and delete, that sort of work together as a unit. So one example would be like if the database represents a bank and the person has more than one account and is moving money from one account to the other, then we've got to take money from one account and move it into another account. And, both of those steps need to go together. Or say we are uh, adding a new employee. So we're going to, add a record for that employee into the personnel, but then we might also place them in a department, assign a manager, and so on. And so a situation like that, then you might put all those steps together and they will define a transaction. Okay. Another thing we want to worry about is that uh, transactions should not cause any anomalies. Now, one thing we did to avoid anomalies was normalize. So, just to remind you of normalization while we're talking about uh, another thing that is meant to avoid anomalies, let's just remind you of normalization. We had this idea of data in tables, and then we sort of broke the tables down into smaller tables to get rid of some redundancy. Um, Now, back in the, I don't know, 70s, early 80s, maybe some of that redundancy reduction was meant to save on storage, but it also, and this was more important as storage became cheaper, uh, avoided update anomalies. So if the employee has some address and different departments across the enterprise may need that address at some point, then without the normalization, without the reduction in redundancy, that address will be in several locations. And then if the person moves, that one of those addresses may change and the other one may not. So that's one of the reasons for normalizing now. And so that changes don't make sense that they are have all the effect they should have, no extra effect, and all the effect they should have, and none of the effects they shouldn't have. And transactions sort of go in the same game of let's make sure things are consistent and right, that we have integrity and so on. Okay. So our database is to represent something out in the real world, the data of some company or library or what have you. Um, and so there are uh, consistent states that um, represent at least a situation out in the world that could make sense. And that would be called a consistent state. An inconsistent state would be violating some a rule, some like perhaps business rule of the company. Something is wrong and doesn't represent the real situation. So then we want our idea of a transaction is, a set of steps that move us from consistent state to consistent state. They should not put us in an inconsistent state. So that is again the idea of transaction. Something, we're going to sort of start in a consistent state, then define transactions such that when the transaction is complete, we're in a new consistent state. All right. So an example. Let's say we have some like stockbroker company, and we're going to let go one of the brokers. And the broker had clients, had customers. And now we've got to decide, if we are sort of putting together a, letting go of broker transaction, then we need to know what to do, not just uh, with the broker. Are we going to delete the record? Are we going to just mark the record as fired or what? So there's that. There's that broker's record, but the broker had relationships to clients, and so now we have to decide, in addition, what to do with the clients. Are we assuming that the clients went with them, so they might be marked inactive or deleted, or do they need to be reassigned? Do we give them some like default broker until they're sort of properly reassigned? What are we going to do? We define it. We bundle it all up into a transaction, and then uh, when the broker leaves, we enact the transaction, and it should take us from the consistent state with the broker there to a consistent state with the broker no longer there. Okay. So then there are many steps now, or could be many steps in a transaction. And then we have to ask, if you get through all the steps and you move from the prior consistent state to the post consistent state, then you will say that the transaction is committed. So if you've done anything with databases, you've seen this word commit all over the place. So, you know, add a table, commit, drop a table, commit, update record, commit. Are you sure you're ready to do this? Are you committed? Um, and then you also have to work on, something may have gone wrong in your set of steps in your transaction, and then what? And then you said you're going to like abort the transaction, and then you know the whole idea with the transaction was to take you from consistent state to consistent state. So if something went wrong and the transaction wasn't completed, then you may be in an inconsistent state. So if a transaction is aborted, you may be in a in an inconsistent state, and then we have to figure out what to do about it. This is where the concept of rollback comes. So there were certain partial steps along the way. We have to figure out what was done, what parts of the transaction were done, and we have to be able to sort of undo them, to roll them back, to get things back to the prior state in which was consistent. Okay. Now, it might be that you perform a transaction and there was nothing wrong with the transaction. It went through, but you just realized that it wasn't proper, that it wasn't what you meant to do. Even though you moved from consistent state to consistent state, uh, it was the new consistent state doesn't really reflect the reality of the world that the database is meant to represent. And so then we have compensating transactions, just a another fully defined transaction that undoes that. So we might have a hire or rehire a broker. So if we have a let a broker go transaction, we might have a hire or a bring back um, transaction. So it may be we just use a hire transaction, or it may be sort of different. It may be a bring back transaction, maybe a different transaction. Okay. And again, we are in within SQL, we are in the data manipulation language, the DML. And so there are lots of little individual things, little individual SQL statements that might be all part of a transaction. And so we need to be able to delimit the transaction to say where it starts and where it ends. So there are keywords in the data manipulation language for beginning the transaction, for committing the transaction, for rolling it back. And so, again, we need this idea in the database. And so we have parts of the language to support it. Okay. We always say that a transaction should respect the acid test or pass the acid test. And so the acid is ACID, A atomic, C consistent, I isolated, D durable. So it should be atomic, like considered like a unit, that it is all or nothing. Consistent, it should take us from consistent state to consistent state. So we've been talking about those two. And then now isolated, that's going to be more interesting. And then as we sort of the next talk or video or two on transactions, this will become more important. But a transaction should be independent. It should not interfere with another transaction. And that's going to be a whole host of issues. So that's going to be interesting and the material for further discussion. And then durable. Once the transaction has been committed, then it should be, permanent, that it should be, you know, effectively saved, committing, if you finish a transaction and you commit it, then it should be lasting, that result should be, in the database. And, if the system were to go down and needed to be recovered, it should be that completed transaction should be part of what is recovered. All right. So a database, we can work with like little individual databases just on a single computer, but a real sort of database management system has uh, a lot of parts, a lot of architecture. And so in this diagram, we're seeing that there are all sorts of interactions with the database to be managed and scheduled and so on. And so we're just going to mention some of them within the context of transaction. So there's a transaction manager, somebody who's going to interface with users or applications to find out what they want done. Then, especially when you have multiple users and that idea of isolated, uh, transactions have to be sort of scheduled. When are we going to do them? And so that is part of the database management system. Something may go wrong in the database as a whole, or the system as a whole may go down and have to come back up. So there should be something to help with recovery. And then there's just the basic of moving the data, you know, back and forth between storage is the more memory is sort of what we're working on, and storage is that more durable, permanent thing. And so we need something to sort of manage the back and forth. So when we're doing a transaction and it has not been completed, and it's probably mostly in memory, and then now we're committing it. Now we're probably sort of putting it into storage, sort of actually saving the results. Okay, so that's it for this one, and but more to follow, especially this idea of sort of concurrency, that idea in the acid test, that I of the acid test, um, to can we, how do transactions possibly interfere with each other, and how do we handle that? Okay, thanks for your attention.